seem to be in equilibrium. I already explained what equilibrium is in finance, especially. So I already defined the equilibrium as there's no surplus of demand or supply, right? So if you take a look at the page number 53, there's some definition of equilibrium. So according to the textbook, equilibrium price can be defined as the price that balances buy and sell orders at any given time. So when a stock is in equilibrium, the price remains relatively stable until new information becomes available and causes the price to change. So as intrinsic value is going to be changed always due to the what? The cash flow is changed, right? If the cash flow of the company is changed, then the intrinsic value or the price. Can you hear me? You cannot hear me. Virginia, you still have the problem? Virginia.
Professor, Virginia just left the room to rejoin.
Virginia just got out of here.
Yeah,
I
she
think
said she's going to
she
rejoin.
tried to log in, I think. Okay. So it's okay to the student. You can hear me? All right. Okay. So the efficient market, let me keep going. So efficient market is the intrinsic value. If the intrinsic value is equal to the market price, then we would say that's the efficient market. So the major research to change the stock price or intrinsic value is because why? As I told you, we define the stock price or the firm value as the present value of future cash flows, right? So if the future cash flow is changed, then the intrinsic value is going to be changed. Okay, so those kind of things is the we'll say the information. Okay, so if those kind of information comes out, then the stock price is changed. But there's some the time lag. 또 이러네. This happen again. So due to some right technical problems of the network problem, I think. Okay. So it depends on the how new information can be reflected stock price. How fast? Okay. So if we say if the new information is reflected the stock price immediately, if the new information is reflected the stock price immediately, then you'd say those market is efficient market. I cannot handle it because this is a network problem. It's okay in the morning session, but I think in this time there are a lot of the lots of traffic, I think. Okay, so if there is this signal means it is more likely to be the network problem, then I will stop my talking. Okay. All right. So the efficient market. So if new information is reflected to the stock market immediately, then you'd say those kind of market is efficient. Okay. So we'll say there are three forms of efficient market. I I moved to the place, so the facilities changed. So I can see your face very well. Okay. So my facility, I have another monitor. So I have now two monitors. I have two monitors, so I can communicate with you very closely now, right? So there are three forms of efficient market. We would say weak form efficient market, weak form efficient market, semi-strong efficient market, strong form efficient market. So the efficient market has three forms. Efficient market has three forms. So it depends on what information is. Okay, so if the market is weak form efficient, then historical price or volume. So stock records. Historical stock record is considered as the weak form, weak form efficient market. So in weak form efficient market, historical price or volume play a role as information that can be reflected stock price immediately, right? How about semi-strong form? In semi-strong form, we consider historical price or volume historical price or volume as well as publicly available information. So in semi-strong form, we can think the publicly available information as well as historical price or volume is reflected in the stock price. Then we'll say those kind of market is semi-strong form market. Strong market is the historical price or volume, publicly available information, and internal information. So in semi-strong form efficient market, historical price, publicly available information, and the internal information are reflected in the stock price immediately. So if market is weak form efficient, then we can make profit if we use publicly available information. So the example of publicly available information is the financial statement or disclosure by company. So if market is weak form, then you can make the profit by using financial statement information or disclosure. Another example, if market is semi-strong form efficient, then we can make the profit only we can use the internal information. Okay, so market can be classified by three forms. Market can be classified by three forms of efficient market. Depends on what information is reflected at the stock price. Okay. And the final topic of financial market institutions is behavioral finance. So behavioral finance, what is the behavioral finance? Even if market is efficient, but there's some phenomena that we cannot anticipate, we cannot expect. That is called as abnormal, market abnormal, market anomaly, we would say market anomaly. Anomaly, market anomaly. There are tons of phenomena that can cannot be explained by traditional finance theory. Okay, so which is called as market anomaly. Then why those kind of phenomena happen? Because human being is not logical, not rational. So basically, most of financial theory assume that human being is logical and rational. But in real life, as you know, human being is not logical or the rational, right? Rational thinking. So there are a lot of the phenomena that human beings are not rational or logical. So those kind of phenomena can be explained by behavior finance. Okay, so behavior finance means the we can explain some phenomena that cannot be explained by traditional finance theory. Okay, those are behavior finance. For example, we'll say January effect. January effect means if we study rate of return on every month, then during for the last 100 years, then January rate of return is the highest out of 12 months. So everybody knows, for example, this is January, but we do not know why January return is the highest. We cannot explain by using traditional finance theory. That's because, so we can only explain the reason why, human being expect the beginning of, expect the rate of return, the high at the beginning of each year. Okay, so expected. So we can reflect the expectation of each year. Okay, so those kind of things is called as, so there are a lot of the phenomena, but we cannot explain that one by using historical, traditional finance theory. Another example is if we make the empirical study, which day has the highest return, then the result is Friday display the highest return out of other 7 days, not 7 days, 5 business days. Why is that? We cannot explain that one due to some human beings reason, right? Human beings reason. So we cannot explain those kind of phenomena by using traditional finance theory, right? So just human being, tomorrow is the weekend, or is happy. So if the human being feels happy, then they can make the money. It's illogical, right? So everybody knows today is Friday, but Friday's return is the highest. How can we explain those kind of phenomena? That's what behavior finance. So even if we define the several forms of efficient market, but there's some phenomena that violate the efficient market. Okay, which is explained by behavior finance. means because the human being is not logical, it's not rational. Okay, that's the behavior finance. So there are a lot of the reasons, for example, overconfidence, for example, self attribution, finance and the sentiment indicator in page number 57. So if you are interested in the behavior finance more, then you can take the investment. In investment, we will talk about the behavior finance more detail. All right. And the question in chapter 2. Sorry about the network problem, but I cannot handle those kind of problem. So from time to time, the link is disconnected, right? All right. Okay, let's go to the time value of money.
Professor?
Yep.
I had a bad connection when you were describing about the strong form of efficient
Hold on a second,
market.
please. Yeah. Hold on
And
a second. Yeah.
okay.
Okay, what is the question?
I had a bad connection, and I lost
Yeah.
you when you were describing
Everybody.
about the strong form of efficient market. I lost you when you were saying the third factor. Like the first one was historical price or value. Second one was publicly available information, and lost you when you were describing the third factor. What?
Internal information.
Okay. Thank
Internal
you.
information. Let me say again. So in weak form hypothesis, historical price and volume is reflected at the stock price. We would say those kind of market is the weak form efficient market. In the semi-strong form efficient market, then the publicly available information or disclosure as well as the historical price and the volume is reflected at the stock price. That's going to be a semi-strong form the efficient market. And finally, the strong form efficient market, the historical price and volume the publicly available information or disclosure and internal information I reflected at the stock price, then we say those kind of market is the strong form efficient market. All right.
Thank you very much.
All right. The time value of money, the chapter 5. As I announced before, chapter 3 and chapter 4 are all about the accounting. Okay, so if you take the principles of accounting, I think all of the contents are covered by principles of accounting. So I will skip to explain the chapter 3 and chapter 4. But there are some contents that we should know. in chapter 3 and chapter 4. So those kind of contents will be explained in the later on when we talk about the issue related to the what we skipped in chapter 3 and chapter 4, right? Okay, let's go to the chapter 5, time value of money. Time value of money, the chapter is very important thing, very fundamental the chapter. So as I announced before, if you take a look at the putting things in perspective in front page of the chapter 5, page number 156, here you go. Time value analysis has many applications, including planning for retirement, valuing stocks and bonds, setting up loan payment schedule, and making corporate decisions regarding investing in new plant and equipment. In fact, see, of all financial concepts, time value of money is the single most important concept. Okay, right? So, as in the textbook, as written in the textbook, time value of money is the single most important concept. Okay, because this time value of money concept can be applied to several other the topics covered in financial management, right? Retirement plan. So when we calculate, when we estimate the value, intrinsic value of stock and bond, we can use the time value of money concept. If we make the decision whether or not we uh, invest in with the huge expenditure, which is called as capital budgeting. So when we conduct the capital budgeting work, we should also use the time value of money concept, right? And when we estimate the retire the pension, something like that, then we should use the time value of money. So a lot of the topics that we will cover in financial management class, we use the time value of money concept. So you should know, you should be familiar with the time value of money concept, right? Okay, so in this chapter, we will study the future value, present value, annuity, future value, present value, annuities, perpetuity, and even cash flow, interest rate, and amortization, which are topics we will talk about in this chapter, right? So first of all, you need to know the timeline. This is the graph or timeline. Timeline shows the timing of cash flow, right? So the antique marks occur at the end of each period. So basically, we assume that all kind of cash flow occurs at the end of each period. So default of the cash flow occurs at the end of each period. If the cash flow occur at the beginning of each period, then we can tell those kind of things in in specifically. Okay, so default is what cash flow occurs at the end of each period. So time 0 is today. Time 1 is at the end of first period. Year may be period. Period may be year. Period may be month, week, even day, or the beginning of the second period. So at at the end of first period has the same meaning of the beginning of second period, right? So if we receive the money at midnight today, then that money we can receive the money 12:01 a.m. tomorrow. That's the same thing, right? So at the end of first period can be considered as same as the at the beginning of the second period, next period, right? So this the time. The tick mark is at the end of each period. Cash flow, CF, the stand for cash flow, right? This is the time period, 1 to 3. So let me show you the terminology first. PV stands for present value. current value. FV means future value. So the basic concept of the time value of money, I already explained. The $100 today has the more value, larger value than $100 in the future, right? CF is a cash flow. I or R means interest rate. So I use R or I to express the interest rate. Okay, INT is the amount, the dollar amount of interest. PMP is the payment. Payment means the identical amount seriously. This is the payment. So if we receive $100, $100, $100, $100, $100 for 5 years, that is called is the payment. Okay, so payment, basic characteristic of payment is the same amount, and repeat for some specified the period. That's the payment series, right? Same amount series. Okay, that's the payment. N stands for number of period. Okay, so you should be familiar with the terminology to explain the time value of money. Now let's take a look at the future value first. Future value. Future value is the finding the future value of cash flow or a series of cash flow is called compounding. Compounding means the interest on interest, right? Interest on interest. So, for example, if you have $100, okay? For example, if you have $100, okay, and the interest rate is 2%, all of the interest rate is expressed by per year, okay, per year. So for the 1 year, I can receive the 2% of rate of return interest, okay? Then if there's no compound, which means simple interest, then 1 year later, I receive $2 as interest and $100 as principal. The total is $102 if we ignore compound. Okay, if we ignore compound. If we assume that the interest can be compound on every 6 months, if we assume that the compound can be occurred on every 6 months, then we can receive $1 after as interest, because the interest rate is 2%, so I can receive the $2 per year, right? So the after 6 months, I can receive $1. Okay, then if we can compound on every 6 months, then during this period, principal is not $100 anymore, but what? $101. So during the second half, interest can be realized based on not $100 but $101 if we assume if we compound on every 6 months. $2. This $2 is we can receive $1 during this period. We can receive $1 in this period if we ignore compound. But if we assume that we have the compounding on every 6 months, then we can the interest is 100 during the second half. We can calculate the interest based on what? 101, not 100, right? So if we have the compound on every 6 months, then 101. So total is $102.101. So if we assume that we compound on every 6 months, then we can receive $2.01 as interest and $100 as principal. So at 1 year later, I can receive $102.01 at 1 year later. Okay, so it looks like very small gap, right? It's almost same. Not at all. If interest rate is higher and higher, if the amount is larger and larger, if the time period is longer and longer, then this gap is gonna be huge. Okay, so we used to say those kind of things is power of compound. Power of compound. So if you take a look at the page number 163, figure 5.1, figure 5.1, then x-axis is the period, 10 years. Y-axis is the future value of $1. If you have $1, if interest rate is 0%, if interest is 0%, then the $100 today, $1 today is the $1 10 years later. Okay, because interest rate is zero. Interest rate is zero. Okay, so if interest rate is zero, then the today $1 is same as the $1 in 10 years later on. Okay, but if interest rate is 2%, then it's increase a little bit. If interest rate is 10%, increase a little bit. If you take a look at the the graph, if the interest rate 20%, if interest rate is 20%, then the future value $1 is higher than $6. Okay, higher than $6. So if we calculate simply, if 20%, so if we calculate the interest as the simple interest method, then 1 times 0.2 times 10 years, right? So it's gonna be 2. So if we ignore compound, then $1 is gonna be $2 at 10 years later on if interest rate 20%. But if we consider the compound, that is a simple interest. If we consider the compound, it's gonna be higher than $6. Huge difference, right? So if the amount is the larger, the period is longer, the interest is the higher, then this the difference is getting bigger and bigger and bigger, wider and wider and wider. Okay, so we say that's called as power of compound. So we always pay attention to the compound, right? To calculate the intrinsic value, I mean the future value. All right, that's the graph of figure 5.1. That's the compounding. Okay, compounding. So all of the time value can be solved by using step by step, which is also called as formula. If we use the formula, this method is step-by-step method. The step-by-step method is you can use your smart brain, okay, smart brain, or we can use the table, or we can use the finance calculator and spreadsheet, even spreadsheet. So if this class is conducted in the offline, then you cannot use the Excel spreadsheet in exam, right? But this is the online class, so you can use the spreadsheet in Excel when you take the exam. So you should be familiar with method, the how you can use the spreadsheet in Excel to prepare the exam. Okay, And to use this excess spreadsheet is more convenient method to calculate the future value, present value, annuity, something like that. So I will let you know, right? So, and that is the very basic, simple question here. What is the future value is initial $100 after 3 years if interest rate is 10%? So if you have $100 today and interest rate is 10%, then what's future value after 3 years? That's the question, all right? Then this $100, so if you have the 1 year, then interest rate is 10%, so this is 100 times 1.21 at the end of first year. How about at the end of second year? Well, 100 times 1.1 times 1.1 equal to 100 times 1.1 square. Okay. How about the 3 years later? 100 times 1.1 times 1.1 times 1.1. It's gonna be 100 times 1.1 to the power of 3. Right? So this is the way to use the formula or by using your smart brain. So 3 years later, the $100 is gonna be $133.1 3 years later. So if we generalize this case, you say future value after n years equals to present value times 1 plus I or I to the power of n. Okay, so this one 1 plus I to the power of n is also called as future value interest factor. Future value interest factor of R of interest rate and N of years. Okay, so 1 plus I to the power of N, this one can be expressed by FVIF-RN, right? Okay, so we can solve this question by using formula, or if you have the textbook, let's go to the back. The last page, it's almost the last page in textbook, Appendix E. Appendix E. It's almost last page. Appendix E. Appendix E. So if you take a look at the Appendix E, there are 4 tables there. 4 tables there. So table E1 display future value interest factor. Table E2 shows present value interest factor. Table 3 future value interest factor of ordinary annuity. Table 4 present value interest factor of ordinary annuity. So there are 4 tables. First one is the when we want to calculate the future value, simple future value. Table 2 we can use the if you want to calculate the simple present value. If you want to calculate the future value annuity, then you can use the table E3. And finally, you can use the table 4 if you want to calculate the present value of the annuity. Okay, what is the annuity? I'll let you know. Okay, so we may use table to calculate the future value. So if you have the textbook, where is the answer of my question? Yunha has textbook, right?
Yes.
Yeah. So where we can get the answer in the Appendix E? You found out Appendix E?
Yes.
Yeah. So
so it's the first table.
yeah, table. Yeah, first table. First table shows future value of future value interest factor. So we can use the first table to solve this the question. So the question is 3 years. The number of years is 3, and interest rate is 10%. So where is the answer? in table?
1.331.
Exactly, right? So if you take a look at the third row, that's gonna be period, right? 3 years. And if you take a look at the column, 10th column shows the 10% 10% of our interest rate. So if you take a look at the cross point between third row 10th column, then the figure is 1.331, right? So $1 is going to be $1.331 if the maturity is 3 years and interest rate 10%. So the question is $100. So you can just 100 times 1.331 is going to be $133.1. Okay, so you may use table, okay, or you can use the calculator, finance calculator. This is finance calculator. This is finance calculator. I used this one is 30 years ago, but still, Texas Instrument supplied the finance calculator, so it's very convenient. So I don't know, but you can see correctly. So here you go. This is some button, future value, right? Present value, payment, interest, number of period. See? See? So only you can do is what? To click the button. And you can get the answer. Future value, payment, present value, interest, number of period. Future value, payment, present value, interest, number of period. See? So you may use the finance calculator, or the most convenient thing is the way is to you can use the Excel spreadsheet. I will let you know, right? This is the method to calculate the future value. How about present value? Next one is present value. Now, finding the present value of cash flow or series of cash flow is called discounting. Discounting is a reversed concept of the compounding. So I will let you know. I showed you in the figure 5.1. In that there is a compounding, right? And if you take a look at the page number 166, figure 5.2 shows discounting. Okay. So this is the compounding. If you take a look at the figure 5.2, page number 166, period, 50 years. Y-axis is the present value. So present value of $1. So $1 today is gonna be what value? Depending on period and interest. So if interest rate is 0%, then the $1 of today is same as the $1 and 50 years later on, right? How about if interest rate is 3%? If interest rate 10%? If interest rate 20%? So the present value, is a very deep discount, right? If the interest rate is huge, okay. So just reverse with respect to the future value. So this is a discounting, okay. So present value discount. The present value shows the value of cash flows in terms of today's purchasing power. Whereas the present value is $100 due in the 3 years if interest is 10%. So here's the question. If you have $100 3 years later on, then what is current value, present value of $100 today if interest rate 10%? Then the base formula is what? Present value. It's in the last one, right? This one, right? Future value is equal to present value times 1 plus I to the power of n. then if we move 1 plus I to the power of n from right hand side to the left hand side, then present value equal to future value after n years later on divided by 1 plus I to the power of n. I move this equation from right hand side to the left hand side. Okay, so present value can be calculated by future value divided by 1 plus I to the power of n. This is a discount factor. Okay, so we would say 1 plus I to the power of n is called as future value interest factor, right? Future value interest factor, we told us, okay? Then what we would say 1 divided by 1 plus I to the power of n. This is called as present value interest factor. Present value interest factor. Okay, so 1 plus in. 1 plus I to the power of n is called as future value interest factor. 1 divided by 1 plus I to the power of n is called the present value interest factor. So table 2 provide present value interest factor. Okay, so present value equal to future value divided by 1 plus I to the power of n. So 1 divided by 1 plus I to the power of n is called as present value interest factor, which shows in table 2, right? Table E2. So in this case, if we have the $100 3 years later on, then 100 divided by 1.1 to the power of 3 is going to be $75.13. Okay, so we can get the answer by using table where if you take a look at the table 2, Yuna has only guy who has the textbook. 아니야? Yuna,
Yeah.
where can you get the answer? Table 2, right? E2. Period is period is 3 years, right?
Yes.
And percent is
Percent is 10%?
yeah. So what's the figure there?
0.751. No.
Temporally disconnected. Yeah. What's the figure there?
0.751.
Exactly. 0.751. So the principal is $100. So 0.751 times 100 is going to be $75.1. 참 쉽죠? It's easy, huh? Yeah. So we may use the table. That's the present the way to solve the present value. And if you know, see, present value, future value is the in this equation. You can use just only one equation. This equation, right? This equation. So there are four variables, right? 4 variables: future value, present value, interest rate, and number of period. So to solve the, to explain this equation, we have 4 variables, right? So if we know the 3 variables, then you can find the remaining variables value. Okay. So if we know this one, and this one, we can calculate the future value. If we know the future value, interest rate, and the number of period, and we can calculate the present value. If we know the future value, present value, and number of period, then we can calculate the interest rate. If we know the future value, present value, and the interest rate, then we can calculate the number of period. All right. So there are 4 variables to explain the relationship between future value and present value. Then if you know the 3 variables value, then you can calculate the remaining one, right? So we can figure out the future value, present value, and interest rate. Third one is the interest rate. So solve the general future value equation for I. What interest rate would cost $100 to grow to $125.97 in 3 years? This one is $100. $100 is going to be $125.97 during 3 years. Okay. Then what is interest rate? What is interest rate? Okay. So present value is $100. Future value is $125.97. We know the number of period, 3 years. Only we do not know the variable of interest, right? So 100 times 1 plus I to the power of 3 is going to be $125.97. So 1 plus I to the power of 3 is going to be 1.2597. So if we take the 1/3 as exponent in each term, then this is going to be 1 plus I equal to 1.2597 to the power of 1/3. So I equal to 1.2597 1/3 minus 1 is about 8%. Okay, so we can calculate. So to solve this equation, you should use the calculate at at least the financial, the engineering calculator. So right, so you can use the 1/3 as exponent. So to solve this equation in exam, for example, you should bring the engineering, at least engineering calculator, or you can use Excel spreadsheet. Okay, that's the interest rate. Last one is number of period, number of years. To solve the general future value equation for N, if sales grow at a 20% per year, this is can be considered as what? Interest rate, 20% per year, right? How long does it take? How long before sales double? So this is the present value. Future value is double, right? Interest rate 20%. So in this question, we should figure out what? Number of period. Okay. So if you take a look at the questions, also related to the time value of money, then you should figure out the what question is to ask the present value, to ask the future value, to ask the interest rate, to ask the the number of period, or to ask the annuity, to ask the perpetuity, as you shall see later on. Okay, so this is summarized by what? 1.2 to the power of x is gonna be 2. How can we solve this equation? By taking log, right? So x equal to log 1.22. So base is 1.2, number is 2. So how can you solve this one? Log 2 divided by log 1. So number of the years to take to get the double is, the answer is how many years? 3.8 years. 3.8 years. So after 3.8 years, we can have the double. Okay, if the interest rate is the growth rate, sales growth rate is 20%. That's the number of years, right? Number of years. Okay, then how can you solve this one? By using spreadsheet. Spreadsheet. So if you click this icon, then the formula icon is very useful when you cannot remember the exact formula. So if you click this, the special icon, then you can know what happened. So, okay, there you go. Can you see? You can see, right? Yeah, okay. So first question is here you go. You have $10,000 to invest now. You will need the money in 5 years and you expect to earn 8% per year. So the number of period is 5 years and the interest rate is 8%. How much will you have in 5 years? So this question is asked to what? Solve what? Future value, right? You have $10,000 and the 5 years and the interest rate is 8%. So as you know, if you want to call the function key, you first of all you click the what? Equal sign, right? Equal. Here you go. Oops. Reduce. Equal sign, right? Equal. So if you click the equal, then this equal, then the 그래. Then here you go. 이거 보이지? So if you click the equal sign, then here you go. There's a realize, right? The function key window you realize. So now what we are looking for, future value, right? Future value, its name is future FV. So if we click the FV, then you only do what? Just put the cell here. Interest rate is 8%. Number of period is 5 years. Payment, you don't have to think about the payment in this example, in this question, because as I told you, payment, you need to consider payment when we talk about annuity. So payment, as I told you, payment is the equal amount for some specific period, right? The same amount, right? That's the payment. So you don't have to think about the payment in this question. And present value is $10,000. Type, type is the type is set as the cash flow occur at the end of each year, at the end of each period, as default. Okay, so if you want to calculate the when cash flow occur at the beginning of each period, then you should put some number in here. So if you type is the means the cash flow occurrence. So 0 or default is the at the end of each period. If you want to get the cash flow as the beginning, then you need to add number 1. Okay, here you go. So if you don't do anything, then it's gonna be automatically this assume that the cash flow occurs at the end of each period. So you don't have to think about the type if the cash flow is expected to be at the end of each period, right? Then if you click the conform, then you can get the answer. It's negative. So be careful. Excel spreadsheet is so smart, but not as much as you guys. Right? So cash flow, inflow, outflow, we can recognize the cash inflow and cash outflow. So if present value is cash inflow, future value should be cash outflow. If present value is cash outflow, future value should be cash inflow, right? So generally, present value means the money that I have. Okay, so present value can be considered as cash inflow, and the future value should be cash outflow. So if you want to get the positive number, then you need to add a negative sign in front of future value function. Otherwise, it shows negative value, or sometimes the error make some error, right? So $14,693. So here you go. Notice the spreadsheet has the same sign convention as the calculators with positive inflows and negative outflows. The negative sign was placed before the future value formula to make the result positive. See? Okay. So if you want to get the positive number, positive the answer as future value, you should add a negative sign in front of future value. Here you go. And next example is to solve the present value. You need $150,000 in 18 years for your daughter's education. Oh, so the father or mother is preparing the tuition for the daughter, their daughter. I have one daughter. She graduated the college already, but she's now preparing the graduate school. But she want me to still support. Okay, so total education. So 18 years. I think this is the tuition. $150,000 in 18 years. So, and if you can on 6% per year, how much do you need to invest today? So the we want to know how much money we need to invest if we want to get the $150,000 18 years later on. Okay, that's the question. If the interest rate is 6%. So this question is asked what? To solve present value, right? $150,000 in 18 years is gonna be what amount, right? Yeah, today, if interest rate is 6%. Okay, so let me do again. Click the equal sign, and we can find the function of present value. Interest rate is 6%. The number of period 18 years. Payment, you don't have to think about payment. Future value is $150,000. The type, you don't have to think about type. So if you want to get the positive present value, then you can, if we recognize the future value as the cash outflow, then we can add a negative sign in front of future value. Then we can get the answer, $52,552. So if we save or invest $52,552 today, then we can receive $150,000 18 years later on if interest rate is 6%. All right, that's the second example. Third example is about the interest rate. So you have $30,000 to invest and you need $45,000 for down payment and closing costs on a house. If you want to buy the house in 2 years, what are the interest do you need to earn? So the fact is that you have $30,000, 30K, and you want to buy the house 2 years later on. But I need a down payment is $45,000. So generally nowadays here in Korea is the same thing in the state. So generally the states you need to pay 10% or 20% of whole house price as down payment for the first time, and then you can pay during the last 30 years, something like that, which is called as mortgage, right? Mortgage, house mortgage loan. So you can borrow the money and you can repay the principal and the interest during last 30 years or 40 years, even 50 years. So if you repay all of the principal and the interest, then it's time to die, right? Right? That's the common common thing in the States. Here in Korea is very similar to the States situation, especially the Korean the house prices nowadays has been goes up, right? It's dramatically goes up. But all of the thing over the world has the cycle, right? So if some price goes up, then definitely it's time to go down, right? So nowadays, I think the house price is definitely overvalued, I think. Okay, anyway, So $30,000 to invest, you have $30,000, and you need the money, $45,000 as down payment to buy the house. 2 years, then what interest rate should be, right? So interest rate, the function is rate, R-A-T-E, rate. So number of periods, 2 years. Payment, you don't have to think about payment so far. Present value is the $30,000. Oops. Number of period, 2 years. Payment, you don't have to think about payment. Present value is $30,000. Future value is $45,000. You don't have to think about type. If you click the confirm, what happened? What happened? There's some error. Why is that? We did not change sign between future value and present value, right? So future value should opposite sign with respect to present value, as I told you. Otherwise, as you can see, we have just this error message. Can receive the error message. Let me do again. So interest rate, the number of period is 2 years. The present value is $30,000. Future value, we can consider future value as the cash outflow, right? Cash outflow. So we need to add a negative sign in front of future value. And if you click the confirm, then 22%. So if you extend the cell as the 2 decimal point, then 22.472%, right? So we can get the answer of the interest rate, 22.74%. The last example is number of period. You have $15,000 to invest right now. So you have $15,000. You figure out we'll need $25,000 to buy a new car. If you can earn 5% per year, how long before you can buy the car? How long you need to wait to buy the car? If you want to buy the car whose price is $25,000, but you only have $15,000, so $10,000 is not enough, right? So you need $10,000. So how long does we wait to get the $25,000 from $15,000 if the interest rate is 5%? Most of you guys you buy this car as installment, right? By using the loan, the car loan, right? 할부해가지고 다 사죠? 이게 안 기다리지 요즘. Alright. Anyway, so this question is asked what? The number of period, to solve number of period. So equal sign. Let me call the number of period. Number of period function key to solve number of period is NPER. Number of period NPER. Here you go. Interest rate is 9%. Payment at this point you don't have to think about the payment. Present value is $50,000. Future value is $25,000. You should add a negative sign in front of future value. Type, you don't have to think about type. And if you confirm, click the confirm, 5.92758.505 years, right? So it's almost 6 years later on, you can buy the car. But I think all of you guys, most of you guys buy this car at this point with loan, right? Okay, this is the last example of, the out of 4 variables. Okay. So we figure out how can we solve future value, present value, interest rate, and number of period. So you need to refer to this example we talked about to figure out how can we solve. So as I told you, if you take a look at the question related to time value of money, you should figure out what kind of question is, right? To ask present value, to ask to solve the future value, number of period, interest rate, or annuity, annuity due, ordinary annuity, perpetuity, as you shall see later on. As you shall see in the next class, okay? All right, let me stop here. Any question? So this coming Thursday, we will talk about the annuity, perpetuity, and if we have the time, we will talk about installment, right? Any question?
Professor?
Yeah, who is it?
Chong Yunhua.
Yeah, all right, yeah, okay.
Could you tell me one more time about why you put a minus in front of a
Future
equation?
value. Yeah.
Future-
Otherwise, it's gonna be error. So as I told you, Excel spreadsheet recognize that all kind of cash flow has the one direction. Okay. So, but the present value, future value, it has the reverse direction of the present value. Okay. So if you do not add any, the negative sign in front of future value, then it's going to be error. So the Excel spreadsheet, the recognize, for example, 10,000, automatically they recognize the negative sign. So for example, here you go. For example, present value, future value. Okay. So if the present value, then we do not have anything, we do not have anything, then this future value, Excel spreadsheet automatically recognize the, the value we figure out is negative. So if we do not do anything, then it's gonna be, for example, just like negative $12,000. If we do not anything, if we do not do anything. So if you want to get the positive number, then you should add negative sign. Negative is gonna be positive.
Oh, so it already has a minus sign, but to become a plus sign, you have to put a minus in front of it.
Exactly. Yeah, exactly. So you can, if you want to get that positive sign, then you should add a negative sign in front of the future value.
So you don't put a negative sign in other like present value, only in the future value?
No. I know. Yeah. So you can add negative sign either present value or future value. So yeah, as I told, let me explain again. Excel spreadsheet automatically recognize the future value is the cash outflow, present value is cash inflow. Automatically they recognize those kind of things. So if we do not do anything, then future value is expressed by negative sign. All right? Okay. Any other question?
Thank you.
Paul, you are the first class, right? How can
Yes.
you register the registration period is already gone? How can you register this course?
Sorry, can you repeat, please?
It's disrupt. Say again. Yeah. I cannot hear you. Yeah. Say again. Please say again.
I don't know. I don't know if it's working
All right.
now.
Okay.
Yes.
Now I can. Yeah. Keep going. Yeah. Now I can hear you. Yeah.
Perfect.
So how can you register this course? The registration period is gone. Yeah.
Yes, it was nice. Yes. How I register from this course, or how my feeling concerning this course?
I can hear. Okay. Anyway, okay. I see. All right. If you do not have any questions, so let's meet the coming Thursday. All right. In the coming Thursday, we will talk about annuity and the perpetuity and loan amortization. Okay. All right. 야, 참 문제다. 이거 자꾸 저 네트워크이 문제네. 네트워크 problem. But I cannot. All right. Okay. Bye. 예, 누구예요? 누구요? 네. 보충 교재 그거 왜 썼어? 내가 한 건데 그거 사지 말라고 그랬잖아. 예, 그거 써도 돼요. 예. 예, 달라요. 당연히 다르지. 그거는 이제 로스 책을 번역한 거고 이거는 지금 브링엄 책이에요. 그래서 그냥 교재고 이게 주교재라고 그랬죠. 이게 에센셜 오브 인베스트먼트 파이낸셜 매니지먼트. 에센셜 오브 파이낸셜 매니지먼트. 만약에 오프라인을 했으면은 필요할 수도 있었는데 온라인으로 수업하니까 엑셀 스프레드시 쓰면 돼요. 근데 이제 향후에 무슨 뭐 CPA 시험을 본다거나 아니 CPA가 아니라 파이낸스 쪽에 계속 관심이 있으면 은 뭐 사는 것도 나쁘지 않아요. CFA 특히 뭐 CFA 시험 준비한다거나 이러면 사야지. 아니 그게 이제 엑셀 스프레드시트이 자기가 이렇게 인식을 해요. 그러니까 프리젠 밸류는 플러스, 퓨처 밸류는 마이너스로 오토매틱 자동적으로 그렇게 인식하게 돼 있어요. 얘네들이 아무리 똑똑하지만 사람보다 똑똑하지 않기 때문에 그러니까 아예 세팅을 그렇게 해놨어요. 엑셀 스프레드시트이. 프리젠 밸류는 플러스, 퓨처 밸류는 마이너스가 되게. 그러니까 두 개의 부호가 반대가 되게. 그래서 그거를 그냥 냅두면 마이너스가 나와요. 마이너스가. 그러니까 그걸 두 개가 저 부호가 반대여야 되는데 아까 인트레스트 레이싱가 뭐 구할 때 같은 부호를 넣으면은 에러가 뜨는 거잖아. 그러니까 두 부호는 반대가 되게끔 세팅이 돼 있어. 그러니까 우리가 이제 플러스 퓨처 밸류 얻으려면 거기다 마이너스를 붙여야지 마이너스가 돼서 플러스가 나오잖아요. 네, 네. 자꾸 끊기네. 예. 알겠습니다. 예. 또